Running an unmodified generator on HHO. The reason for the modification of standard generators as shown above is due to the fact that the HHO gas mix produced by an electrolyzer ignites about 1,000 times faster than a hydrocarbon fuel, and because of that, the spark which ignites the fuel needs to be delayed. That mechanical adaptation of the generator can be avoided if the HHO gas mix is modified so that it ignites more slowly. This can, and has been done. David Quirey of New Zealand has been operating an unmodified generator and a welding torch on the HHO output from his 6 liters per minute own design of electrolyzer, for many years now. Henry Payne's U.S. Letters Patent Number 308276 dated November 18, 1884, states that HHO gas can be converted into a more convenient gas which is much easier to handle, by the simple process of bubbling it through a suitable liquid such as turpentine or linseed oil. Although unaware of Henry Payne's patent, David discovered the technique independently and he has extended the technology further so that the gas ignition speed can be set manually. One important point which David stresses is that it is essential that the HHO coming from the electrolyzer is passed through an ordinary bubbler containing water, before it passes through the second bubbler containing the modifying liquid. David finds that the lighter liquid, acetone, works better than the liquid suggested by Henry Payne, although white spirit, carbon tetrafluoride, aviation fuel, hexane or even petrol can be used, and any of them will slow the flame speed right down to that of butane. If the flame is being used for a specialist task such as jewelry making or glass blowing, then there may be an advantage in using one particular modifying liquid. Please note that the bubbler holding the acetone needs to be made of stainless steel, as acetone can dissolve some plastics. David has further modified the characteristics of the output gas by adding in a percentage of the unmodified HHO gas. Although it is actually subtle and sophisticated, David's overall system is easy to understand. The ratio of the two gases is adjusted by the settings of the two control valves as shown here. Adjusting the ratio of modified HHO to unmodified HHO allows a high degree of control over the characteristics of the resulting gas mix. Added to that, David has developed an electronic control system which oversees and manages the gas flow rate according to the user's needs at any given moment. The result is a system which allows water and electricity to be the means of supplying a gas which can be used as a safe, general-purpose fuel. If it is used to run a generator, then the system appears to become self-powered if part of the generator output is used to drive the electrolyzer. It should be possible to substitute the modified gas mix for propane or butane and so operate a wide range of existing equipment for heating, cooking and/or lighting. David runs a 4-horsepower Honda generator using this system. The generator runs very well for David. However, I suspect that if cold water mist were introduced into the incoming air, then the power output would be increased due to the mist turning into flash steam and providing greater pressure on the piston during its power stroke. Alternatively, it might be possible to match the present performance with a lesser gas flow rate, possibly powering a much larger generator if that were a requirement. It needs to be understood that David uses electronics which manages and controls the gas flow volume, suiting it to whatever the needs are at any given moment. Consequently, it is probable that the 6 liters per minute which David's electrolyzer can produce, is not actually used for most of the time. David also does welding, brazing and cutting with the same modified electrolyzer gas mix which can provide adjustable flame heat and a flame length of anything up to 2 feet in length. Piercing panel steel to demonstrate high flame temperature and low axial heat. It is a good idea to use a proven design with full control electronics. David can help here with detailed step-by-step construction plans and instructional videos. When using the system for welding, David uses the mains to power the electrolyzer, the arrangement being like this. The flashback arresters are a sand-filled design and so are mounted vertically. The gas production rate is knob-controlled using this circuit. The first part of David Quirey's circuit acts very much like a dimmer light switch. The 230-volt AC mains is fed through an on-off switch and then an ordinary mains fuse. The current flow on through the circuit is blocked by the BT139 triac until it receives a pulse from the DB3 diac, which is a component specifically designed to feed pulses to a triac. As the voltage builds up on the 68 nanofarad capacitor, it eventually reaches the point at which it triggers the triac, which then switches on and remains on until the mains voltage drops down to zero again. The 500 kilo-ohm variable resistor sets the rate at which the capacitor charges up, and so it controls the length of time that the triac is on in any given second, and so, the level of power fed onwards to the rest of the circuit. This happens on both the positive going half of the AC waveform and the negative going half of the main sine wave voltage supply. Both the diac and the triac operate with AC and trigger either 100 or 120 times per second depending on the frequency at which the local mains runs. The current flow is then passed to a bridge rectifier in order to convert the AC into pulsing DC, and the capacitor C1, which is 400 volt rated, smooths the resulting DC. David's cell has a large number of plates and so, operates off the 300 volts produced by the system. The ammeter between the diode bridge and the cell indicates the current flow and so, the amount of gas being produced at any given moment. The flashback arresters are constructed as shown here. Push-fit nylon tube connector. Polyfiber disc. Dry sand. 25 mm ABS pressure pipe. End cap glued on with high pressure rated solvent. 6 mm nylon tubing. Sincere thanks are due to David Query for freely sharing his design and experiences, and for his willingness to provide direct additional support and further details should they be needed. Stan Meyer's water injection system. While the above simple adaptation will work for an electrical generator which is stationary and which is designed to provide large amounts of electrical power, some of which can be used for producing HHO gas from water, it is much more difficult to run a large capacity petrol-gasoline engine continuously with just water as the fuel. For larger engines aimed at producing mechanical output, we need a more powerful system, such as that developed by Stan Meyer of America. Although many years have passed since the sudden, highly suspicious death of Stan Meyer, as far as I am aware, his design has not been replicated, mainly because people do not understand the information which he left behind. However, recently, a man whose forum ID is H2 Power has helped explain what Stan meant, and much of the following description is down to his sharing his understanding publicly and freely. Stan's Canadian patent 2,067,735 has an arrangement where the injector schematic shows the injection into the engine of three separate components. One component is described as ionized gas and ambient air is mentioned. The second component is part of the exhaust gas, which is hot water vapor fed through a limiting valve, referred to as inert gas. The third injection component is a very fine spray of water droplets or cold water mist. This three-component mixture is passed between high-voltage electrodes, and if the mix does not ignite spontaneously, then it is ignited with a spark. One version of Stan's recommended injectors for an existing engine are shown like this. This is a cross-section which only shows two of the three gas inputs flowing through this injector spark plug. Each gas input has its own feed passage which leads out between the central electrode and the circular outer electrode, and each feeder tube has its own one-way valve to prevent the power stroke from forcing the incoming fuel back up its feed tube. This is only one of the ways that Stan shows that it can be done. Here is his diagram for a two-cylinder engine fuel input, although it applies equally as well to any number of cylinders. Let me stress that this is just an explanatory diagram and you do not have the intake and exhaust valves open when the spark plugs fire. Also, the pistons do not go up and down together, but their movement is staggered to give a less uneven drive to the crankshaft. The point to note here is that the fuel intake is through standard valves and ordinary spark plugs are shown. However, this diagram for US patent 5,293,857 is based on the use of an electrolyzer, and Stan found a way to avoid the need for an electrolyzer. For this, Stan's gas processor is a really key device in spite of it being what appears to be a fairly simple construction. It operates by pumping light energy into the fuel components. This may not sound like a big deal, but it most definitely is. In fact, it is the heart of Stan's system. In addition to the extra energy, the fuel components are also stressed by high voltage pulse DC applied in such a way that it tends to pull the molecules apart as they flow past into the engine. The gas processor is constructed from two highly reflective metal cylinders, 96 light-emitting diodes, LEDs, and a carefully adjusted high-voltage pulse DC source. The reflecting tubes are used to make the light bounce backwards and forwards indefinitely until it is absorbed by the passing molecules. The choice of LEDs is very important as the wavelength of the light needs to be matched to the resonant frequencies of the fuel components passing by. Laser LEDs can be used, but they need to be angled slightly in order for them to bounce and completely fill a section of the gas processor gas passage. The operation is simple in concept. 6 banks of 16 LEDs are installed in the outer cylinder, which has a polished inner surface. To see the effect of each LED, consider just one LED on its own. The LED light shines onto the inner tube, which has a highly polished outer surface. In the diagram above, the light is shown in red, and the uppermost LEDs of the 6 columns of LEDs can be seen. The light is then reflected back to the outer cylinder again. The reflected light is shown here in yellow, although it is identical in wavelength to the section shown in red. This reflected light is again reflected by the outer tube, and that repeats over and over again until the whole of the area between the two tubes is completely filled with the light. This will happen with just one LED, and that light will continue to be reflected backwards and forwards indefinitely if it does not collide with a gas molecule. That is the effect of just one LED, but there are 6 LEDs at that level, each producing light of the same frequency and reinforcing the power of each of the other 5 LEDs, producing a very powerful overall band of light. The same thing happens in the vertical plane with the light bouncing all the way down the tubes, and as the LEDs at different levels generate different wavelengths, there is a powerful interaction between the different frequency waves, producing intermediate frequencies by a process with the technical name of heterodyning. In this diagram, it has not been possible to show the way in which the reflected light from each LED interacts with the light from all of the other LEDs, but there is a complete intermixing of the beams. The LEDs are shown with greatly exaggerated size and spacing in order to give a reasonably understandable diagram. The diagram above barely indicates the level of light intensity inside the gas processor, and that is from only 6 of the 96 LEDs actually installed. It is a little difficult to visualize this device, but the gas, of whatever type, flows up through a circular donut-shaped space between 2 pipes and is hammered by a very high level of light energy of the appropriate frequency. H2 Power believes that the optimum LED frequencies are as shown here. And while, not surprisingly, I have not been able to find an LED supplier for these exact frequencies, most LEDs emit a band of frequencies rather than just a single frequency, so the working LEDs need to include the frequencies shown here. The operation of the gas processor is further enhanced by applying a pulsed high voltage between the inner and outer metal cylinders. This voltage stresses the molecules of the gas flowing between the 2 cylinders, and because it is pulsed, it applies a tugging action on the molecules, tending to pull them apart. As with all high-power free energy systems, having the device operate in resonance is very important. If it is still available, the excellent video, http://www.youtube.com/watch shows what resonance circuit operation is all about. Briefly, the frequency of the driving waveform passing through winding A in the diagram above, is adjusted until almost no current flows through that winding. This is the same as tuning a radio to a particular radio station. In both cases, the signal at that frequency finds it almost impossible to drive any current through the winding. This would make you suspect that almost no current would flow in the output winding, but that is not the case because that current flows into the secondary winding from the local environment. After all, here is no electrical connection between the 2 windings, so common sense tells you that the electrons flowing in winding A do not flow out of the other winding. This resonant operation gives you a major energy gain courtesy of the local environment. The objective of the gas processor is to modify whatever gas is flowing through it, air, water vapor, HHO, or whatever, to one of its highly charged, highly energetic states. The high voltage applied to the metal cylinders of the gas processor does not flow through the gas between the cylinders. Instead, it provides a very high electrostatic plus charge on the outer cylinder and a very high minus charge on the inner cylinder, and these two opposing charges pull the charged parts of each molecule towards themselves. The positively charged gas ions get pulled towards the negative inner cylinder and the negatively charged gas ions get pulled towards the positive outer cylinder. Stan uses this technique on the incoming air when he uses an electrolyzer to power an engine. However, Stan's preference is to use air, water mist and some of the exhaust gas from the previous power stroke to power his engines. This is an effective method as H2 Power states that he has blown part of a car engine clean through the bonnet of the car, and that indicates that there is plenty of power available from those three components, although, ideally, you want to get the timing right and not overstress the engine. One thing that H2 Power points out is that the injectors supplied for converting any car to run on alternative fuels such as natural gas, can be adapted to be the equivalent of Stan's specialized injectors, if a pair of high-voltage electrodes are added to each injector and fed from a pulsed circuit such as Stan's voltage intensifier circuit. The arrangement would then be like this. A220, page technical brief from Stan Meyer at http://www.freeenergyinfo.co.uk/meyerdata.pdf can be downloaded free, although it may well provide you with more information than you ever wanted to know about the subject. Peter Lindemann's lawnmower running on water alone. Peter Lindemann has shown that a much simplified version of Stan's injection system can operate small engines directly on water alone. Let me suggest that it is not the water which causes the explosion, but instead, that the high-power spark causes dissociation of some of the water vapor, producing hydrogen and oxygen which then ignite, turning the remainder of the water vapor into flash steam, making the engine operate as an internal combustion steam engine. The http://www.youtube.com/watch video shows a lawnmower engine operating on a spark which occurs 10 or 11 degrees before top dead center. Developed in conjunction with the Energetic Forum, the technique is based on the Aaron Go-to-look style of operation with the circuitry shown in this video. http://www.youtube.com/watch. Although the direct hit spark booster shown at http://www.poolstar.com/directhits.cfm might well make the circuitry easier. Obviously, using this technology to operate a standard electric generator would be a major objective, especially since there appears to be little need to adjust the existing spark timing much. Peter Lowry's high current electrolyzer system. Peter Lowry of New Zealand developed an electrolysis system for use with internal combustion engines. Like the previous systems, Peter feeds a spray of fine water droplets into the engine, using a carburetor, supplied by a water tank. He also feeds in some exhaust gas and heated HHO gas, which is a technique which is almost identical to Stan Meyer's method. Peter also produces a very large volume of HHO gas with a most unusual method. He uses a delta-wound, GEC marine alternator, though he says that the alternator from a truck would do. He modifies the alternator by removing the diodes inside it and leading each of the three-phase windings out to his electronics. He uses each of the three-phase windings to power one electrolysis cell. He applies only 2 volts or so to the DC winding of the alternator, which is about the minimum which allows the alternator to work. The DC current supplied is less than 1 amp while the pulsed current to the electrolysis cells is much higher. When a snap-on ammeter surrounds the wires to the cells, a current of at least 800 amps is displayed. A point of particular interest is the inductor coil, placed between the electrolysis cells and the windings of the alternator. Peter describes this as a choke-out of a three-phase industrial power supply. It is comprised of a laminated steel core with a sheet of copper wound around it. This is remarkably like the arrangement used by Stan Meyer and already described earlier in this document. Peter has run a 1,600 cubic centimeter car engine at 5,500 RPM with the gas output from his cells. He believes that his method of cascading the gas output from the cells through each other, produces a more active form of HHO gas. He also uses a heat exchanger which allows the exhaust to preheat the HHO gas before it is passed to the engine, a method also used by Stan Meyer for running a car on water alone. Peter also uses impulse-operated valves to control the flow of gas to the engine as shown here.